Okay, this video will cover question 14 and question 17. Okay, now first we have to prove that D is the midpoint of AC. Alright, so this is the information they have given us already. Okay, this one you can go and read the question. So first and foremost, what I'm going to do is this. In order to prove that D is a midpoint, alright, I will prove that triangle DEC, okay, is similar to triangle ABC. Okay, so how I do that is first I say that angle DCE is equals to angle ACB. They share the same angle. This is a common angle. Then I also know that angle CDE is equals to angle CAB. This is equals to 90 degrees. This is because this information is given. 90 and 90. So therefore, I can say that triangle CDE is similar to triangle CAB. And this is because of angle similarity. Then now I think about it for a while. If CDE is similar to triangle CAB, I will now know that I will try to go for CD, okay, CD and CA. So I'll try CD over CA. And the other ratio that I will know will be CE is to CB, because we have this ratio is 1:1. So I say that CE over CB. Now I go that CD over CA. CE over CB, we know the ratio to be 1/2. So I'll know that CD is half of CA. Since CD here is half of CA, so therefore I can conclude that D is the midpoint of AC. And I have proven part 1. 14 part 1, we have to prove that D is the midpoint of AC. Okay, through the use of similar triangles. Now, I need to prove that triangle AEC is an isosceles triangle. Basically, you want me to prove AEC is an isosceles triangle. Looking at the diagram, I think that the easiest way to do this is to prove that triangle AED, okay, is congruent to triangle CED. Once it's congruent, I can say that these two lengths are equal. Hence, I'll prove that the two triangles, that triangle ACE is an isosceles triangle. So now I'll set about to prove that these two triangles, AED and CED, are congruent. So, first and foremost, let's get started. Okay, I will know that the length of AD is equals to the length of CD. This one I know, right, because D is the midpoint. Okay, D is the midpoint of AC. Okay, so I have one side, then DE is common because they both share DE. Finally, I also know that angle ADE is equals to angle CDE equals to 90 degrees. This is 90, angles on a straight line. This angle must be 90 as well. So finally, if I have all this information, this one side, I have an included angle and I have another side. So I can conclude that triangle AED is congruent to triangle CED. And the proof here is side angle side congruency. Then, since triangle AED is congruent to triangle CED, alright, comma, I will therefore know that the length of AE is equals to the length of CE. Okay, then once I know that AE is equals to CE, I can therefore conclude that triangle AEC is isosceles, as it has two equal sides. And I'm done with question 14. Now I'll move on to the next question, which is question 17. Okay, question 17. Okay, this is the diagram from the book. Okay, you please take note, right, that you do not need to copy out these diagrams. Okay, I copy them out so that it's easy for me to explain it to you. Basically, it is this. Okay, I know that first part, let's label things that we know. Okay, the lines are parallel, and AE is to AC is 1:2. So therefore, I know that AE is equals to EC, because AE is to AC, the ratio is 1:2. Okay, now first part, they want me to prove that the BF, okay, is to FC. Okay, no, sorry, BF is to BC, okay, is 1:2. So basically, they want me to find this ratio, BF is to BC. So I would think that we will use similar triangles in this case, okay, to prove this ratio. So now, for me to start off this ratio, I'll prove the triangle EFC is similar to triangle ABC. EFC, ABC. So first, I will start by saying this. This is part 1. I'll say that angle ECF, this angle here, is equals to angle ACB. Alright, and this is common. Next part I will say is angle FEC, this angle here, is equals to angle BAC. Okay, this one is corresponding angles because EF is parallel to AB. Therefore, triangle EFC is similar to triangle ABC, and this is because of angle similarity. EFC is similar to ABC. This is because of angle similarity. Okay, now first part, BF is to BC. Okay, BF is to BC. So therefore, I will know this CF, okay, or FC, okay, is to BC is equals to EC is to AC. And since it's already given to us, okay, EC is to AC, so EC is to AC, I know that FC is to BC is equals to EC is 1, AC is to 1:2. This relationship is actually given to us already. EC is to AC, alright. Okay, so therefore I will know that therefore FC is to BC is equals to 1:2. I have shown. And that is 17 part 1. Okay, 17 part 2, what they want me to show is this. AB is to CD is equals to AB is to CD. The ratio must be 1:1. Okay, now in this case, what I'll do is to show this, I will show that triangle AEF is similar to triangle ACD. Okay, so I begin. AEF, ACD. So first I say angle EAF is equals to angle CAD. This is because they have a common angle. It's actually the same angle. Next thing that I know, alright, okay, I say that angle AEF is equals to angle ACD. This case is because of corresponding angles. Okay, and this case is because EF is parallel to CD. Therefore, I can conclude that triangle AEF is similar to triangle ACD. Okay, I pause for a short moment and that's what we have. Okay, AEF is similar to triangle ACD by angle similarity. Now this is what we will say. Since AE is to EC is equals to since AE is to AC is equals to 1:2, okay, then now similarly, because AE is to AC is 1:2, correct? So therefore I can also say that AF is to AD is also equals to 1:2, okay, because they are similar triangles. Then, so therefore I can conclude that since AF is to AD is 1:2, F is the midpoint of AD. Okay, since AF is to AD is 1:2 folding, F is the midpoint of AD. Then next thing here, I can say this. Notice that now E and F are the midpoints of AC and AD. So E is midpoint, F is also midpoint. E is midpoint of AC, F is the midpoint of AD as well. So I can write this, since E and F are the midpoints of AC and AD respectively, I will therefore know that EF is equals to half of CD. Okay, what I'm employing here is the midpoint theorem. So therefore, okay, I repeat, E is the midpoint of AC, F is the midpoint of AD. So these two are midpoints. By midpoint theorem, EF is half of CD. If you can't see this, just rotate the paper. Okay, EF will be half of CD by midpoint theorem. Then I conclude that CD is 2 times of EF. Simple algebra here, we just multiply both sides by 2. Okay. Then I can also say that since E and F are the midpoints of CA and CB. So basically right now I'm looking at it from the other side. I say that F is a midpoint, E is a midpoint of CA and F is a midpoint of CB. So E and F are the midpoints of CA and CB. So therefore by midpoint theorem, EF is equals to half of AB. Therefore AB is 2 times of EF. Okay, so 2EF is equals to AB, 2EF is equals to CD. So thus, okay, so AB is equals to CD. Since they are equal, alright, quite simply put, alright, I know, hence AB is to CD is equals to 1:1. And I am done with question 17. It's a slightly more complex question, so do take some time to actually look through the question and think through the logic or why I did certain things to prove that AB is to CD is equals to 1:1. And thank you for watching.